So today's lesson is going to be focusing on piecewise functions. So it's going to be functions still, but where we have functions that are made up of different pieces or different functions. So the definition is a piecewise function is a function that is a combination of two or more functions. So go ahead and fill in the two blanks, the parts in blue, piecewise and combination. And it's pretty much a rule for a piecewise function. The rule is different for different parts of or pieces of the domain. And we'll get more into the word domain tomorrow. All right, so for instance, think of a movie ticket. So movie ticket prices are often different for different age groups. So the function for movie tickets would assign a different value or a different price based on the domain, which would be the age. So if you can have like student tickets, adult tickets, children tickets, and free tickets for kids under 2 or something like that. So again, those would be the different pieces of the function in this case. All right, so what do they look like? So we have two functions or more, so we have to have two functions within one single function f of x. So we use this little brace or this bracket, and we have x squared plus 1 being the first function and x minus 1 being the second function. The first function exists for x is less than 0, and the second function exists for x is greater than or equal to 0. So when it comes to graphing piecewise functions, they sometimes look something like this. So we can graph them or we can evaluate them. We're going to be evaluating today and graphing later on this week. So here's a piecewise function that has 4 pieces to it. As we look at it, we have 4 parts to it. This right here would be the first piece. This right here would be the second piece, third piece, and the fourth piece. So the first, second, and third pieces are all linear functions, increasing, decreasing, and constant. The last piece is half a parabola, or 1/2 of the parabola. All right, let's look at another piecewise function. This one you do not have on your paper. This one's also made up of 4 pieces, each piece being a linear function in this case. So we have 1, 2, 3, and 4. All right, so that's just kind of what they look like. So let's go ahead and get into actually how do you evaluate a piecewise function. So you can evaluate based on the given graph or based on the actual function itself. So let's look at just going back to evaluating a regular function. We know how to find f of 3 and f of -8 for the function 5x plus 2. You're not writing this down, but just as a quick recap, all you do is substitute. So you plug in the number 3 for f of 3. So 5 times 3 plus 2, 15 plus 2 is 17. If I did f of -8, I plug in the number -8. I get -40 plus 2, which gives me -38. You guys know how to do this. You've done it a million times. Now, when it comes to evaluating a piecewise function, so when we have a function like the one given to us right here, how do we find f of 5? So when I plug in f of 5, so you need to pick the correct function using the domain, meaning I want to find f of 5, and I have to use one of these two to tell me, do I pick the top one or the bottom one? So based off of this, 5, is 5 less than or equal to 3, or is 5 greater than 3? And the answer should be 5 is greater than 3, which means I need to use the bottom function. So again, we're being asked to find when x equals 5. 5 is greater than 3. As a recap, you will substitute into the second function. So we're going to be using the second one. So we're going to be plugging -5 plus 4. And that's going to give me -1. And my 1 is missing for some reason. All right, so let's go ahead and just write that one in real quick. But that's the general idea. All you do is decide which of the two based off these guidelines, which we call a domain. All right, let's go ahead and move on. Hold on, that's not even supposed to be there, so just -1. Ignore that 13. I don't know where it came from. So we can also evaluate f of 1. This one's on your paper. It's the very first one, the very first graph. So when we have f of 1, we have to look at the graph. We have to look for when x, this tells me when x is equal to 1. All right, where were we? I'm sorry, I think it cut off. So let's try it again. So we're looking for when x is equal to 1. This right here tells me x is equal to 1. So this is where 1 is on the x-axis. So I want to see where does my graph exist at this point. So I'm going to go ahead. I'm just going to draw a line. You don't have to draw the line. So which function does it belong to? It's on the right side. So right here. So we see, you don't have to draw this line, that this green line that I just quickly drew here for visual effect at 1 hits the function, my little blue line that's slanted down, at this point. It hits it at the number 3. So at this point, it hits it at y equal to 3 or f of 1 equal to 3. So I would say f of 1 is equal to 3. Go ahead and write this on your paper. So one more time. At positive 1, where does it hit the function? It hits it right here. At 1, it's 3. Let's go ahead and try the rest. So go ahead and try out -4, 5, 0, and -6. Feel free to pause it. Otherwise, we'll just go over it. So as we're looking at these, at -4 is right here. It's a function on the left side. And this one hits it right here. So that would be at -3. Let's look at the next one. Let's go ahead and try when we have 5. Positive 5 is here on the right. It hits it right here on this dot. That's at -1. Here is 0. Let's change that color. So at 0, this is a 0 between positive and -1 on the x-axis, and that hits it here at the top, which is at +4. And last one we have at -6. Here is -6. And this hits it right here, which is also at -3. So that's a general idea of evaluating functions when you're given the graph. You just look where the point hits it. All right, let's go ahead and clear this out and do the next one. So we're going to do one more. And actually, it's not on your paper, so you're going to have to write it in yourself. So make sure you write down f of 6. This one's not on your paper. So this one is a tricky one because on this one, we have 6's over here. But if we look up or down, it doesn't hit either one of those two lines. So this one, there is no actual answer here. So what do we do for this one? And we have no solution for it. So we're going to just write down that it's right there. There's nothing. There's undefined. So we either use the words undefined, or you can also put does not exist if you prefer. All right, let's go ahead and move on to the next one. Let's look at this one. Go ahead and pause it and try it out, and then check your work. So please pause, answer them. Okay, now that you have your answers, let's go ahead and see what you guys got. At 0, at 3, at -2, 6, -5, and 7. You should have gotten at 0, you got 0. It's at the origin. At 3, you should have gotten 1. At -2, you should have gotten -1. At 6, you should have gotten -6. At -5, +3. And at 7, if you got -5, it's actually wrong. So it's actually undefined as well, because that circle we have here, this circle right here is an open circle, which means it doesn't exist right there. There's no actual point there. It's just a space holder. So at 7, it's undefined. Got to be careful with those. They can be tricky. All right, how about evaluating piecewise functions when you actually have the function, when you have to plug it in, like that example I did earlier? So we're going to evaluate these three at f at -3, 6, and 0. So for the first one, -3. So which of these does it satisfy, the first one or the second one? Is -3 less than 0 or greater than 0? It's actually less than 0, so we use the first function, 2x plus 3. And we plug in our -3, we get -6 plus 3 is -3. So I skipped the extra step there. If you want to write it in, it's -6 plus 3, which gives us -3. All right, for the next one, we're going to go ahead and decide, is 6 less than 0 or greater than 0? It's greater than 0, so we're going to go ahead and plug it into the second equation. 3 times 6 is 18, minus 4 is 14. All right, next one, we have 0. Is 0 less than or equal to 0, or is 0 greater than 0? It's less than or equal to 0. So we're going to plug it into the first equation. So 2 times 0 plus 3. 0 plus 3 is 3. All right, let's try number 2. Same idea. We just have 3 functions here instead of 2, and we have to just make sure we decide carefully. So when we plug in the number 1, is 1 less than -3? No. Is 1 between -3 and +2? The answer is yes. 1 falls between these numbers because 1 is not greater than 2. So we're plugging into the equation in the middle. So we get 1 plus 4, 5. Next one, -5. Is -5 less than -3? Yes. So it's going to go in the first equation. So we're going to just square it. sorry, that's not coming out very well. Let's actually remove that. You write it in. This is going to be equal to 5 negative, and we're going to square it because we're using the first function. What's negative 5 times negative 5? It's positive 25. Now for the last one, 4. Is 4 less than negative 3? Nope. Is 4 between negative 3 and positive 2? It is not. And is 4 greater than 2? And the answer is yes. We're going to plug it into the very last equation. So we're going to get 4 minus 1, which gives me 3. All right, we're going to go to the next slide. Go ahead and try number 3 on your own. Pause the video and then check out your answers after you are done trying it out. So your turn. All right, now that you've done number 3, let's go ahead and make sure you have it correctly done. H of 2, which equation did you plug it into? Should have plugged it into the middle one. So you should have gotten 2 times 2 plus 3 equal to 7. Next one, negative 7. You should have plugged it into the first equation, which is just equal to 4. There's no x, so there's no negative 7 to plug in. So kind of tricky one. But again, since there's no x, it's just always going to be 4, no matter what negative number below 3, negative 3 you plug in. And the last one, 4. 4 is going to be on the second equation because of the between negative 3 and 4, but it's less than or equal to 4 here. So it's this one right here. So we're going to go ahead and plug that in. 2 times 4 plus 3 gives us 8 plus 3, answer of 11. So that's the general idea of how to substitute functions and piecewise functions and evaluate when we're given a number. Just have to make sure you always check which one it goes into. It's a choice, not all 3, just one of the 3 or one of the 2 or however many equations you have. All right, go ahead and start your practice and good luck.